Hey guys, let me start. Thanks for joining once again. My screen is visible to everyone. Can you guys confirm, please?
Yes, sir.
All right.
Yes, sir.
Thank you, guys. So just let me settle this one. Okay. All right. So everyone join. Thank you so much for joining the session. Okay. So let me share my screen. All right, guys. Thanks for joining the session. Let's start the session. And today we are going to discuss the first module.
सर एक मिनट एक क्वेश्चन का आंसर दे दो बस। सर आज है ना थोड़ी सी दिक्कत आने लग रही है, कल मेरा इंटरव्यू है। स्प्लिट होराइजन रूल का मेरे को एक मोटा मोटा आइडिया दे दो, छोटा सा आइडिया दे दो बस। मेरे को पूरा पढ़ना पड़ेगा नहीं तो। स्प्लिट होराइजन रूल का मोटा मोटा आइडिया दे दोगे सर?
BGP split horizon rule you are asking, right?
Yes.
Anyone know in the class?
Still, yeah, split horizon is used to avoid the loop, so that the route that is advertised from the any router, it will not come back to and receive by the same router if it is routed through the number of routers.
Just I read in one word. Thanks, by the way, Anurag. Don't teach my father or don't teach father, right? एक हमारा बहुत अच्छा फ्रेज है, यही स्प्लिट होराइजन रूल होता है, राइट?
Yes, sir.
समझ आया सौरभ? नहीं आया? एक्सप्लेन करना पड़ेगा मुझे। व्हाट इज
सर एक बार आप हिंदी में बता दो, एक बार बस।
कहाँ पे इंटरव्यू है?
कल है ये HCL में।
SCL में। सो स्प्लिट होराइजन BGP स्प्लिट होराइजन रूल जो हमारा है, वो हमारा ये बोलता है, राइट, कि इसका लिखने का मतलब यही था कि डोंट टीच माय फादर, डोंट टीच फादर, राइट? एनी BGP router, basically BGP router, that means IBGP router, okay,
जी
will not advertise rule, right, from another IBGP peer. Let's suppose there is three routers, R1, R2, and R3. We all running the IBGP. So any route you are receiving from here, right?
यस
Let's suppose you are advertising 1.1.1.1. It will reach to this peer. It will receive this route. But due to the split horizon rule, it will not advertise this IBGP peer. So the BGP split horizon rule is a process where if we are running the IBGP, only it is going to work in the IBGP, where any route is coming to learn from the IBGP neighbor, that is not going to advertise to its another IBGP peer. So let's say हमारे पास एक ये राउटर होता, इससे R2 कनेक्ट होता, इससे एक R3 कनेक्ट होता, इससे एक R4 कनेक्ट होता, इससे एक R5 कनेक्ट होता, ठीक है? यहाँ पे सब में IBGP चल रहा होता. This also running the IBGP, this also running the IBGP, this also running the IBGP. So any LAN segment, let's suppose we have the LAN segment 10.10.0/24. This will reach to this. Let's suppose here we are running the static or EIGRP, and you want to advertise in the BGP. This will reach from this neighbor to this neighbor, right? This will receive this prefix, but this will never advertise this peer. This will never advertise this peer. This will never advertise this peer because of the split. Let me use another color. Because the process which is known as the that is, oh my god, what happened? Okay, so what I'm trying to say, that is the rule that is known as the split horizon rule. ठीक है सौरभ? ओके,
यस सर थैंक यू सर, थैंक यू।
ओके,
पता चल गया सर क्यों मैं राउटिंग मजबूत करना चाहता हूँ।
कोई बात नहीं। फारूक क्यों नहीं पढ़ रहे हो आप अभी?
फायरवॉल मेरा पोलो अल्टो का सर्टिफिकेशन आ तो गया सर।
अच्छा आ गया, शेयर
हाँ
नहीं किया आपने लिंक्डइन पे, हमें टैग नहीं किया।
सर, लिंक्डइन आपको अभिषेक सर टैग है।
अच्छा टैग है,
हाँ
गुइनर को भी टैग करना चाहिए ना, इफ यू डन द सर्टिफिकेशन।
हाँ
एनीवे,
सर।
थैंक यू सो मच फॉर योर सर्टिफिकेशन एंड वंस अगेन कंग्रेचुलेशंस, ठीक है। ओके एंड विश यू ऑल द बेस्ट फॉर टुमारो इंटरव्यू। पास हो जाना तो बता देना, ठीक है। और ये भी बताना क्या क्या क्वेश्चन पूछा गया, ठीक है सौरभ।
यस सर वो सारी चीज बताऊंगा।
डन। सो थैंक यू सो मच गाइज फॉर ज्वाइनिंग द सेशन।
आजकल तो सर आज आजकल तो सर एचआर ही ये सब पूछने लग गए हैं।
क्या?
मतलब कि 10 क्वेश्चन एचआर को दे देते हैं, पकड़ा देते हैं, उसके बाद तो इंटरव्यू शेड्यूल करवाते हैं।
ओके, हाँ थोड़ा सा मतलब शॉर्टलिस्ट करने के लिए ये सब
हाँ
तरीके। Anyway, let's talk about the Palo Alto Firewall today, guys. So may I know the name people who join with the Vivo 1920? May I know your name, please, if you don't mind?
Yeah, my name is Brijesh.
Your name is Brajesh. Okay, thank you so much, Brajesh, for joining the session. I'll just rename, so would be great when I just speak to you. Okay, so total 14 people are here. Thanks for joining. But let's start, okay? So officially, we are discussing about the module that is the module 1. All right, everyone excited? This module 1 is more about the theory part, but this is the most important module to crack your any future interview. It could be the L1 level, could be the L2 level, could be the L3 level, and could be the L4 level. So you should understand each and everything about the module 1, right? Why I'm talking L1 should also know, L2 should also know, L3 also know, because when you go for the Palo Alto interview, might be you are the fresher, right? And you just done the CCNA and you just done the Palo Alto Firewall to just get the job in the market. So you are basically going to be very unique skill set when you're going to appear in the interview, because already you have done the CCNA and the firewall knowledge. So your unique, your skills are very unique. So people will expect at least you should know little bit idea what is the single pass architecture, what is the Palo Alto firewall architecture, what is the flow logic. Similarly, if you are going to promote from the L1 to L2, you are going to get a higher salary. L2 to L3, L3 to L4, and even more manager architect. Even this is going to be asked. And if you don't know the basic things, people will not going to ask the complex things. So these are the base, fundamental of the Palo Alto. Means how the packet processing is going to happen. So day 1 to day 100 day means whatever you are going to do the learn. Just giving the example, you always have to leverage, always have to use these concepts. So you must have to be, much and more focused about this particular concept. That is a single pass architecture, the flow logic. So in first session, means in the first page of this session, we will trying to understand flow logic. Means if any packet is going to be processed by the Palo Alto firewall, then what is the logic it is going to use? How the packet is going to flow within the Palo Alto network? That we have to understand. Everyone understand? And this understanding is quite complex in terms of the diagram. Let me show you. So if I go in the diagram, you are going to find this kind of the very complex diagram. So it's quite difficult to understand, but I'll try to break in the multiple like small pieces. So you are going to clearly understand how the packet processing is happening. You can see it's a quite number of blocks with a number of colors, and each blocks having a multiple processing. So it's very hard to remember as well. It's very hard to explain as well. But anyhow, you have to digest this. And one more important, we are starting this class with this Palo Alto packet processing. And we are going to end also this class with this Palo Alto packet processing. This is also very important, guys. Note my special remark. Why I am talking? Because when I'm going to explain today, you guys are going to get or grasp 30 to 40% only. It's very difficult. You're going to grasp almost 70%, 80%, or 100%, right? So if you're even grabbing the 50%, just hold your thoughts. It's normal, right? But when I break the topics, right, in application section, content ID, because even the syllabus, these all are the dedicated sections we have. You can see we have the routing sections here. You can see we have the security policy, we have the routings, we have application ID, we have the content ID, we have the decryptions. You can see we have some user ID, we have the VPN solutions, right? We have the HA. So most important, these modules and these routing and security policy. So you don't have the knowledge right now because I didn't explain these all, but I'm just going to tell the packet flow. So what is the meaning of telling this packet flow? So meaning is that you understand the complexity of this particular learning, and also initial day you are going to in little bit like complex scenario, but once we just start breaking these small parts, and I just start showing the different kind of the blocks as a small chunk, you are going to get, and at the end of the session when I just explain each and everything again, you are going to get 100% complete understanding. So you don't have to worry about that, okay? But still I try to make a very simple thing so you can understand like maximum thing without any problem. So what is going to be happen in a packet flow, and what does mean? So in packet flow, what is going to be happen? Let's suppose you are the network administrator, you are the security engineer, SOC engineer, and the question is going to ask, let's suppose this is the user and try to access the google.com, right? This packet is going to process via the LAN switch, might be the routers. There is no router, then it is going to hit the firewall. So when the packet is going to receive by this firewall, what is the first step, right? First step done by the firewall. And then what is the second step? What is the third step? What is the fourth step? Means till the time packet is going to stay in the Palo Alto firewall, what all step is going to be happen in the Palo Alto firewall, right? So this is the key things we have to understand. Before this firewall is going to send packet out to the internet, google.com, how the Palo Alto is going to treat those particular packet. Clear? So let me explain now. So if I go in this particular packet flow, you can see this is my packet. So let me draw one of the diagram here. Let's suppose this is my firewall. This firewall might be I'm going to connect one of the interface. This is the one interface. This is another interface. This is the ATS 0 by 0. Let me ATH 0 by 0, right? There is another interface, might be the ATS 0 by 1. And we have the, let's suppose one of the client connected here. This is the PC, and here we have the server connected, right? S1. So this client want to talk to the server. This is the normal use case. So when the packet is going to be initiated by this client, so this packet is going to be come via the wire, right? And this packet is going to hit to this particular interface. That is your physical interface. So once this physical interface is going to receive this packet, when the physical interface is going to receive that packet always known as the ingress packet, right? You can say receive packet, right? You can say input packet, right? So these are the three terms we can use to any packet which is going to receive by the firewall. Clear? So that's why here it is written as the ingress packet, receive packet, in packet, input packet. It could be any name. All right, guys. Similarly, when the packet is going to be sent out from firewall, when the packet is going to be sent out from firewall, this is known as the ingress packet. This is known as the out packet. This is known as the transmitted packet, right? So these are the another term you should know about when the packet is going to send out from the firewall, that is known as the egress interface. Where the packet is going to receive, that is the ingress interface. So whenever people are going to ask what is the ingress interface, what is the egress interface, you should know about it. So you see, in the last, we have the transmitted packet, we have the egress interface. First, we have the ingress interface. That means we receive the packet. Clear? So now, if I receive the packet, what is the first step my Palo Alto Firewall is going to do that? My packet having a lot of information. So out of those information, what information Palo Alto Firewall is going to grab to just do the processing. So let me draw one of the packets. So let's suppose this is one of the packet. Let me use some different color. Let me just clean up this one. So we'll have the better view. Okay, leave it. So what I'm trying to make. No, not this color. So this is one my packet, okay? This packet having a lot of informations. My packet have some kind of the different information. So let me just draw some blocks. And after drawing the blocks, I can just write some information here. Okay. So most of the case, you are going to find the source MAC, right? The layer 2 information, destination MAC, sorry. DMAC. We have the source IP. Source IP. We have the destination IP. We have the source port as well. Source port. We have the destination port. We have the application, some additional data. And finally, we have the payload, which is known as the data. Okay, guys. So in this packet, we have the lot of informations. So these information basically we known as the, let me draw it. Layer 2, this information is known as the layer 3. This information is known as the layer 4. This is my layer 7. Some additional information. Let me add it. Additional info. And finally, we have the content, right? Content is your data. So one packet is going to carry that much information. So out of that much information, we'll discuss each and everything. Layer 2, layer 3, layer 4, layer 7, right? Some additional informations and the final payload. When the firewall is going to receive the packet, the first thing they are going to extract that is your layer 2 address, layer 3 address, and layer 4 address. This is the first thing, means out of this big packet, they are going to get out the information that is the layer 2 information, layer 3, and layer 4 information. Right? Also, you can see here, they are talking about after extracting the information layer 2 and layer 3 and layer 4, they also try to look about the interface, means what is the interface on which the packet has been received. So in my case, you can say this is the interface, which is my Ethernet 0x0. So this is my interface on which interface I received the packet. So this is my interface. Also, they are trying to look a zone. What is the zone of this interface? So might be you don't know what is the zone. So right now you just note a special note on your notebook or anything like copy or pen, whatever you have. Zone is one of the things you have to configure for the every interface except HA and the management interface. There is two types of the interface. One is the HA, which is known as the high availability, and the management interface. Apart from any interface you have, like we have the layer 2 interface, layer 3 interface, we have the VLAN SVI interface, we have the loopback interface, sub interface. Always you have to go and define the zone. So zone is the mandatory thing on the Palo Alto Firewall for the every interface except the HA and the management interface. So zone information is also going to be extracted to the get the information. So that extraction also going to be happen here. Okay. So now we have the layer 2 information, layer 3 information, layer 4 information, interface detail, and the zone information. We'll discuss what is the zone. We have the special topic about it, right? So you don't have to worry about this. You can see here, we have the special topic about the security zone. So we'll discuss what is the security zone. So you don't have to worry about that. Now, once they are going to get that information, what next? They are going to check the packet which I receive on my interface that are basically fragmented packet or unfragmented packet. What does mean? Anyone know what is a fragmentation? Anyone in the class who know about the fragmentation? You must be done CCN and CCNP. What is the fragmentation?
सर छोटे छोटे टुकड़ों में.
Very nice. छोटे टुकड़ों में पैकेट को तोड़ देना. Right? Any other answer, guys? Anyone to give? Which packet is going to be chunked in the छोटे छोटे टुकड़े? कौन से पैकेट को करना? हर पैकेट को करना होता है, कोई स्पेशल पैकेट को करना होता है, या क्या डेफिनेशन है? थोड़ा और टेक्निकल हो जाते हैं इसके लिए हम. इंटरव्यू में पूछा जाएगा तो यू जस्ट हैव टू गिव द आंसर ना. कि सारे पैकेट को तोड़ते हैं, कुछ पैकेट को तोड़ते हैं. तोड़ने के पीछे लॉजिक क्या है? जरूरी है हर फ्रेगमेंटेशन करना है क्या हर बार? Anyone in the class?
The packet is more than the MTU size, that is 1500. Because larger packet cannot be transmitted over the media.
Very nice, Anurag. So every transmission media, like you have the interfaces, they have default MTU size. By default in Cisco, we have the 1500 bytes of the MTU size. So you can transmit the packet up to 1500 bytes, right? But let's say suppose the packet I am receiving, just think in this way. Let me use something. Just think in this way. Yeah, just go. Leave it. This is your one pipe, okay? This is your one pipe. And this can only carry the data with size is 1500 bytes or might be something else. And you have the bigger side pipe which is coming from outside and trying to send the data on this pipe. What is going to happen? Let's suppose this is a water. So your overflow is going to be happen. Make sense? So if this overflow is going to happen, means I need to lose some data, or might be I have to keep in the buffer and all. So this is the problem. So similarly, what you have to do that this cannot be adjust the size which is greater than the maximum size. So we have the overflow, or might be entire packet could be lost if the something is solid material. If there is a water, then can be might be some small portion of the water can be propagated through this pipe. So similarly, if we have any kind of the situation where my packet is basically more than 1500, if my packet is more than 1500, so what is going to be happen? My interface is not going to accept those packets. So if the acceptance is not going to happen on my interface, then what is going to happen? My packet is not going to process, my data is not going to process. So if I have the bigger size of the packet, and this size is suppose 6000 byte, and this is my one of the router interface. This interface is just Ethernet interface, Ethernet 0x0, which can accept maximum 1500 byte. So you have to break this packet into 4 packets, right? And each size would be the 1500. So you have the 4 packet, and then you can easily process the packet. Then it is going to process the packet and it will reach to the, let's suppose this is a firewall. So via this interface, let's suppose the gig 0x0 and this Ethernet 0x0, we have the interface, or might be the Ethernet 0x0 also. These 4 packet is going to receive by particular this firewall. Now, actually your packet size was 600 byte, and now you're receiving the 4 packet of 1500 byte. So this packet is fragmented packet, right? So you have to make sure you have to do the reassembly to just understand entire content inside of which is having the packet. Okay. So this is the region here. The firewall, when receive the packet, they will check whether this packet is actually fragmented or non-fragmented. If it is fragmented, then it is going to do the reassembly. If it is not fragmented, then it is going to simply process the packet. So this is the second or third step after the ingress interface and the zone and the L2, L3, L4 extractions. They will check the fragmentations. Now still the packet is not processing inside the firewall. It is just stopping at the firewall gate when you receive the packet, and they are trying to see what is happening in this particular packet. Now the next step, once they have this all information, they will try to check the packet which I receive. Actually, this is the valid packet or invalid packet. If my packet is not valid, is invalid, if it is the invalid, then simply the packet is going to be discarded. If it is the valid, then it is going to process to the next step. Clear? So what is the criteria to analyze the packet is valid or invalid? What is the criteria to analyze whether the packet I receive, that's the valid packet or invalid packet? So to understand that criteria, we have to go a little bit down in this document. So let me go there and explain you what is the criteria to declare this packet is invalid. And you should know about that. So here are the things, right? These are the things. If my packet having any of these criteria, right, this packet is going to declare as the invalid packet. Okay. So what is this? What is this? First one is mismatch of Ethernet type and IP version. Mismatch of Ethernet type and the IP version. This is the first criteria. Means if my Ethernet is getting mismatched, we have the Ethernet type, we have the IP version, like the IP version V4, IP version V6, we have the Ethernet trunking protocol, like we have the ISL, we have the .1Q. So different Ethernet type we have, right, where we can just send the packet in the switching environment. And also we run the IP, IPX and the IPv6 as well. So IP version also we have a different, right? So if anything is going to mismatch, right, the packet is going to be dropped. It should be the same Ethernet type, what I have configured, what I received, what I have the IP version, what I received the IP, that both are the same. Clear? The first one is clear to everyone. Just say yes, or might be thumb your raise your hand if it is clear to everyone. Second one is truncated IP header. What does mean truncated IP header? By default, may I know how many bits we have in this IPv4 packet? How many know about that? How many bits we have in the IPv4 packet by default?
32.
Yeah, 32.
32. So we have the 8 of the 4 octet, right?
Yes.
Right, 8 bit in the all sections. So what if some IP I receive that which have the 29 bits or might be just 24 bits? Is it the valid IP address? That is not a valid IP address. So any IP header which is less than 32, right? That means their header has been truncated. So this is not going to be accepted by the Palo Alto Firewall. So that packet is also going to be discarded. Clear? Any protocol number which is protocol number 0, that is not going to be accepted. We have a lot of protocol number, but 0 is never going to be processed. Let me show you. So if we just go and search the IP protocol, number list. So you are going to find a lot of IP packet. And let me go here. And you can see the first one is protocol number 0. And this is IPv6 hope by hope option. And this is not going to be used. So this packet is always going to be discarded. This packet is always going to be discarded. Simple definition. So any packet which have the IP protocol number 0, that is not going to process as well. Now we have the fourth one is TTL value 0, right? Any packet which have the TTL value 0, that is also not going to be processed. By default, you have to be set one TTL value. If there is no TTL, TTL is time to leave. So the packet is not going to survive in the network world. It is never ever going to even travel from one hop to another hop. So that's why it is a very important. Your TTL value should be there more than 0, not should be 0. If 0, you cannot send the packet from one PC to another PC even. So that is also one reason when TTL value is 0, this packet is not going to be entertained. Now we have the land of attack and we have the ping of death. These are the two concepts we have, land of attack and ping of death. If these two are also going to be, available in a packet, that is not going to be acceptable by the firewall. So what is the ping of death and what is the land of attack? Anyone have knowledge about this?
DOS attack and DDoS attack.
Yes, very nice. Exactly. DOS attack and DDoS attack. So if I talk about a land of attack, that is known as a denial of service attack. There is a kind of the DOS attack. So in a local network, if any kind of the denial of service attack is going to be happen, right, by doing the spoofed packet from any computer, any malicious source to just hijack our network, destroy our network. So those kind of the packet is not going to be processed by the Palo Alto Firewall. Similarly, we have the ping of death. It's more about the ICMP. We keep saying like denial of service, like in the form of the ICMP. So this is also going to destroy your network. So both are the DOS and DDoS category. One is like any TCP based attack, any IP based attack. Ping of death is just based on the ICMP attack. So anything is going to be happen. It is going to be destroy your network. So the firewall is more capable and they have the intelligence. When you configure the DOS and everything, they understand which is my DOS attack, which is DDoS attack, and which one is my legitimate traffic. And based on that, they are going to allow or disallow the packet from the network. So even I have the land of attack and ping of death, that packet is not going to be processed. So clear till here, everyone. Any questions? Please ask me if you have question. Next, we have the Martin IP address. What is the Martin IP address? Anyone heard about Martin IP address?
The
Anyone?
IP address which is not exist in the internet.
Yes. Dipanshu, you know each and everything. Where do you know?
I have seen
Good.
your video, the same
Okay,
session.
good. Very nice. So Martin IP address is the IP address that exists not in universe, not in entire world you can think about, not world, entire universe. So that IP address is the Martin IP address. Means invalid IP address. Simple in definition, invalid IP address. So here we have the invalid IP address could be any IP address which is not going to fall from the class A, class B, and class C, class D, and class C. Let's suppose I'm going to write IP address in 1000.1000.1000. So will it not going to be? This is not going to be valid IP address. It is not going to fall either the class A, class B, class C, class D, class E, whatever we have, right? We don't have to fall in this, but this is the Martin IP address. And last but not least is the IP checksum error. So any packet which have the IP checksum value is the they have not a valid checksum. They have the error in checksum. So they are going to be discarded. So checksum, I believe everyone know about that. Every packet have to do the checksum processing when they have to pass to the Ethernet checks, IP checks. So always they have to do a checksum, CRC and all. So based on that, if packet is going to be fall under the error, that is going to be discarded. So these are the different method By leveraging these different methods, the packet is never going to be processed if any of things is going to be appear in the packets. So in that scenario, also my packet is going to be discarded at this stage, and it is not going to process by the firewall. Clear? So in last 35 minutes or might be 30 minutes, we'll just discuss 3-4 blocks, right? What is happening when the packet is going to be processed by the firewall. Now let's suppose till here everything is good. The packet you receive, that is a valid packet. There is no error at all. Everything is fine. Then it is going to ask, the firewall is going to ask, the packet which I receive, the big packet which I receive, do I need to do the firewall inspection? Do I need to do the firewall inspection, or simply I can go and process the packet, send out? So what does mean? So firewall inspection means I have to inspect entire packet. I have to check each and every detail of the packet. I'm not just going to check the header of the packet, label of the packet, and going to switch the packet. Router what does? If router is going to receive any packet, it simply check the IP header. Means what is your source IP address? What is your destination IP address? Is consult the routing table, and packet is going to be sent out. Nothing more information is going to check by router. It is not going to check, hey, what port number you are going to use, what the MAC address you are going to use, what application you are going to use, what data you are going to use, nothing. Simply switch the packet based on the header. MPLS what does? MPLS means you have the packet have a lot of information, but they just check the label. Based on the labels, they just switch the packet. They are not going to check what is inside of your packet. You're switch, what they do that? Based on the information, they just check what is the source MAC, what is the destination MAC, and they just switch the packet. Simple definition is going to happen. But firewall having the more responsibility. But even in firewall, you want to just check the header and switch the packet. That is known as the inspection is not required. Means firewall is also going to check the header, and simply the packet is going to be sent out. You can see here. Means if I'm saying the inspection is not going to be applied for that any packet, we have to create the bypass policy. That means the firewall ever is not going to check what is my everything about the application content, data, URL, virus, content. Means nothing is going to be checked. DOS, DDoS. It simply process the packet from ingress to egress, like the router route this like this way. See, the simple packet will come here and it will go, and it will reach to destination and go out. Make sense? So this is known as the if inspection is not available. So now the question is going to be arise, do I really need this inspection? The answer is no. If you are going to say to firewall, no, I don't want to use inspection. So why you purchase the firewall? You can do this routing by the router, na? आप router use कर लो, switch use कर लो. Who is going to stop you, right? So you can use anything, but firewall have this special purpose. Firewall must have to do the packet inspection. That's why you pay the premium amount, and by paying the premium amount, even you are not going to use that particular feature, then waste of the money. You have too much money, you just want to destroy it, right? So every firewall should have the inspections. Some special scenario, troubleshoot scenario means any case, I have the very complex case, something is not working, I want to bypass to just check whether my firewall is doing any blocking or not. Then we can use this firewall inspection applicable. We can disable it. You can just bypass it. Then it is going to come in a picture. Rest it is going to always there. So my firewall inspection is going to be applicable. The answer is yes. Then it is going to check the next step. And what is the next step? The packet which I received, that it's the IPsec packet, SSL VPN based packet, or plain text packet. Understand, guys? This is very important. Still in the ingress stage, This is my firewall. Firewall receive one packet. It's an interface Ethernet 0x0. It want to send this interface to connect the server, but before it is have to do a lot of things, and you should know that. And finally, last thing we have in the English is it is going to check the packet which I received. This is the encrypted packet or non-encrypted packet. Means if I have the IPsec tunnel terminating on the firewall, and those tunnel are receiving the traffic from another site, could be the client to site, could be the site to site solution. So definitely the packet which is coming from the encryptions via IPsec, they always going to be encrypted. Means encryption have the two method. We have the tunnel mode, we have the transport mode. Tunnel mode, transport mode, one is going to encrypt entire packet and going to add a new header. One is going to leave the header and just going to encrypt the data packets. So we'll discuss each and everything in very detail when we discuss the IPsec. So if my packet is encrypted, right? So before the packet is going to be processed inside the firewall, first I have to decrypt those packets and I have to check what is inside of the encryption packet. Why it is important? Might be if there is a virus, might be there is some kind of the malicious content is going on. So we have to protect them, or might be some application you are trying to access that should be blocked by the firewall. How come to know? How I come to know? Only when I just open the envelope, when I decrypt your packet, then it is only possible. So in that scenario, decryption engine comes in a picture in the very first place of the firewall, and this is known as the IPsec SSL VPN tunnel decryptions. And based on that decryption, your entire IPsec packet is going to be decrypted and going to be converted in the plain text. And once it is going to convert it in plain text, again the entire process is going to be happen again. Because earlier the step was happened, earlier the processing was happened, that was the based on the headers of the packets. Whatever topmost header was there, L2, L3, L4, based on that, but data which was just carried by the header, that was encrypted. So now we have the open the packet, we have the new header, new information. So again, we have to do the rethings, everything, whatever we have done in the first place. So now if the second time packet is going to receive by this firewall, this time definitely the packet is going to come as a plain text. So if this is going to come as a plain text, then it is not going to send to this engine, because it is only going to send this engine when this packet is encrypted. Any question till here in the first block? Anyone? What is the life cycle when the packet is going to receive here, here, here? What does means here, and then firewall inspection? Anyone? Are all clear? बताओ मुझे. इतने शांत क्यों सब लोग? समझ नहीं आ रहा है? All clear? Shall I consider? Everyone understand?
Yes, yes, clear.
Okay, thank you guys. Don't worry, don't worry. I know you guys are a little bit nervous, but don't worry. Life will be easy.
I have one query. Like, if this is following entire process, so it is very time consuming. So do we have anything else that we can make it in
Yeah,
shorter
this
time?
is a really very nice question, right? Bridges. Actually,
Yeah.
I was supposed to get such kind of questions because we have to do a lot of things. So it's really a good process to do that, or it's a time consuming delay and all. We'll get an answer. Okay. I'll come to
Okay.
this point. Okay. We'll get an answer.
Oh.
All right. So definitely, as per my explanation, it is going to take a lot of time time consume, but it is not the case. We'll see how it is going to happen a very fast way when the packet is going to receive, and you don't have to worry about any delay parts. If it is going to have that much delay, then the packet processing is going to be very difficult for the Palo Alto Firewall. So now, once we clear with the ingress stage, then in an interview point of view, guys, one of the famous questions, we have the slow path and we have the fast path. So in Palo Alto interview, when you're going for the Palo Alto interview, they are always going to ask the difference between the slow path and the fast path. And 90% people, or I can say more than 90% people, are going to give the wrong answers. Trust me, this is the reality. This is the reality. Whenever the people are going to ask the actual packet processing, they are going to give the wrong answer. So you guys make your note, whatever I'm going to tell now. So I'm assuming whenever you go for the interview, you give the right answers. Because fundamentals must be clear, then only you can crack the interview. So now, again, let me draw the firewall. We done with the ingress stage processing. Now the packet is going to enter in the firewall stage. Means it is going to inside of the firewall. So if the packet is going to inside of the firewall, what is the first thing the packet is going to do that? So as I explained that, these are the next generation firewall. So next generation firewall maintain the session table, right? As I explained that, they are going to maintain the special session table. And based on that session table, they are going to do lookup of the session and then your packet is going to be processed. Clear? So what is going to be happen? Any new packet which is going to be arrive from ingress stage, it is always going to land in the fast path. It is always going to land in the fast path. Any new packet or any old packet, old session or packet, whatever you can just say that, session packet, whatever you can say that, it always going to land in the fast path at the first place. And this is where people make the mistakes, always. So again, I am repeating, any packets, any session which is going to process by the Palo Alto Firewall, it must first check in the fast path. And when you go in the slow path, if the session is not available in the fast path, then it is going in the slow path. Okay, so let me recap this concept with this slide, so you guys might be understanding in better way. So I explained that, right, in this diagram. If you remember the like basic foundation sessions when I discuss about the stateful and the stateless firewall. In a stateful firewall, whenever we just go and process any the packet, this is the user, they have this IP address, they want to go on the Google. So first they will hit the firewall and this firewall will check the policy, right? So we have to create the policy. The very first packet always go and check the policy, then it will go to the destination. But what is going to happen for the second packet? Can anyone remind me? I just forgot about this. I forgot this concept. Anyone remind me? What is going to happen for the second packet? I forgot my concept. Who is going to remind me? First packet always going to check the policy, but when this user want to go again Google for second time, this is the first time, it want to go in second time, then what is going to be happen?
We'll check the session table and forward.
Yes. So what is going to be happen? In first place, when the packet is going to be processed by the firewall, firewall doesn't have any session. Okay, firewall doesn't have any session, so it will check the policy, it will check the routing, right? It will check the NAT. Based on that, they will create one session. Based on that, they will create one session and they will install one session corresponding to this packet in the session table. So if my packet is again going to the same destination with the same source, it will not going to check the policy. It will just check the session and go out. Third, it will check the session, go out. Fourth, it will check the session, go out. Means always it is going to check the session and then it is going to out. And here the slow path and fast path come in a picture. Everyone understand this concept? Please put yes in the chat. Raise your hand, thumbs up if you understand. If you want to say yes after mute, you can say that also. If you understand, everyone. Anurag, understand. What about others? Kapil, Ram, Sachin. Just put me a chat if you understand. Okay, I have replied. Thank you, guys. Good. I like that. So now we have to correlate this concept with my packet flow. Okay. So let me go in my packet flow again. And if I'm going in packet flow, so the same packet, when the firewall is going to receive the packet, this packet is going to be processed via the fast path. This packet is going to be processed via the fast path. Either this is the new packet or this is the old packet. It always go and try to check the session, right? How it will go to the policy? If there is no session, then it will create the policy. If there is a session, let's suppose this is a session table, the firewall will simply consult and go here, destination. But there is no session, it will check the policy. So here slow path and fast path come in a picture, guys. So my always, either my new packet or old packet, always going to check the session lookup. And if session is going to be found, the packet is going to remain stay in the fast path. The packet is going to remain stay in the fast path. If session is no found, then the packet will move to the slow path. You will understand the logic. Okay. Again, I'm repeating. If any packet is going to come from the source or destination, it will always go in a fast path. If my session is going to be found, let's suppose I have this source, right? And want to go this destination. If there is a rule, there is a policy based on source IP address, destination IP, just an example, some port number, they will match and they will just go for the next processing. If there is no session, they will move to the slow path. So what is the slow path and what is the fast path? So fast path is something where your everything is ready to just process the packet. Means you don't have to create session, you don't have to wait for the session. You just have to receive the packet and send to the next processing. Slow path is something when you don't have the any session, you have to go in the slow path. After going in slow path, you have to create the session. So session creation always going to happen in which path? Can someone tell me which path is going to create session? It's slow path or fast path?
Slow path.
Slow path, right? Understand everyone guys? जिसको समझ नहीं आ रहा प्लीज मुझे बता देना. मैं पूरी कोशिश कर रहा हूं कि I can make you understand in one time, right? फिर भी नहीं आया तो बता देना मुझे. So process is going to be happen in the fast path. Processing is going to happen. But if there is no session found, it is going to move in the slow path. And in the slow path, three things is going to be checked to just create one session. And what are three things? First, always it is going to check the routing. So routing is very important. You should good understanding of the static routing, OSPF, you have the BGP, you can configure the RIP. All four are supporting by the Palo Alto firewalls. The first is the routing is going to check. Here layer 2 MAC level forwarding is going to be checked. Second is your NAT processing, right? NAT policy, NAT processing. Third one is your security policy. If the packet you receive that, if that packet having the routing informations, that packet having the NAT informations means correctly configured in the firewall, that packet having the security information correctly configured on the firewall, those all are going to be processed and they are going to check whether have the valid rule or not. If rule is valid, it will create the session, see here, and install this session where? In the fast path. So this is the slow path. Slow path is just to create a session based on the three things: routing, NAT policy, security policy. If it is available for particular packet, it is going to create the session and it is going to install the session in the session table. You guys understand, right? So what is the slow path? What is the fast path? Who is going to explain in the one line or two line? Anyone? Hindi, English कैसे बताओ? What is the slow path? What is the fast path? बताओ मुझे.
In fast path, when the session is available, so it will remain the packet in the session fast path only. If session is not available, it will forward to the slow path, and slow path will create the session.
And in slow path, what things
Yeah,
it
it
is
will
going to
check
check?
the means routing. It will check and NAT policy and the security policy. Then it will create the session and forward to the fast path.
Very nice. Thank you so much, Dipanshu, for your great answer. And I'm expecting everyone understand in such way, right? So अगर आप लोग अभी इतना मेहनत कर लोगे तो इंटरव्यू क्लियर होना 100% है. ठीक है, अभी से थोड़ा इतनी तैयारी करके रखो आप लोग. Next, so we are clear about this particular block. We are clear about here. ठीक है, मैं थोड़ा और 25-20 मिनट और लूंगा आप लोग का, right? And then I'll make entire understanding about this particular packet flow. What next? Let's suppose again this package is going to become, same packet is going to come from this ingress stage. What is going to happen in second, when the second packet is going to be come from the ingress stage with the same source, same destination, which was just created the session? Is it going again in the slow path or it is not going to go in slow path? When the second packet is going to come for the particular source and particular destination and particular application, will it go in the slow path or will it not go in the slow path?
No, it will not go on the slow path. It will directly hit the fast path.
Yes, definitely. So this is the key thing, guys. Once the packet is become old, means one time process, it will never go in the slow path until we have the session valid. Session timeout also is going to be there. Okay. If there is no packet for infinite period of time, there is no packet, then it then means session is going to be always there. No, there are by default 3600 seconds. You can customize it. You can just increase, decrease based on your choice. We'll see that how it is going to be happen. But yes, there is a timeline for the TCP and UDP packets, and according to timeline, the packet is going to stay in the firewall and just stay as an active session. If the till time there is no session, no packet is going to process. Let's suppose you send the one packet now, and next 10 hours you're not sending any packet. So next 10 hours your session is not going to be available in the firewall. No, it's not like that. The session is going to be terminated when you initiate the again packet for the next after 10 hours. It will do again all the process and create the session, and also it will keep the session till next session timeout period. And based on that, your packet is going to be processed. All right. So my fast path is going to be considered when all new packet is going, sorry, my fast path is going to become always in consideration when always my old repeated packet is going to come, not a new one. So once I have the repeated packet, old packet, it will go and check the session. Session is found definitely if my repeated packet. Then it will do the L2 to L3 processing, L4 processing. Earlier it was just extract the informations. Means just check the layer 2, layer 3, layer 4 information. So don't be confused why we have extracted the information here and what we are doing the processing. Processing means as per your policy, it is going to check what is your source IP address, what is your destination IP address, whether this is allowed, this is blocked, this is like protected. I mean, could be anything. If you have the DOS attack, it is going to be protected. If decryption, it is going to be decrypted. So processing is going to happen. And you can see another word is written here, discard packet if session is not active in state. So this is also most important. If session is not active, discard those packet. Also, if the packet is coming and I have the session lifetime, let's suppose 5 hours, and after 1 hour again packet come. So again, I just repeat, means increase my session time 5 hours. So it is going to be update the session lifetime as well. Also, it is going to do the NAT. See, So NAT is very key concept, guys. In slow path, we have to do the NAT policy lookup. Okay. And here we are saying again, we do the NAT applicable. If it is NAT applicable, just do the NAT. So we have to also understand what is going to happen while creating the session and what is going to happen when we are just going to process the packet for any NAT. So for time being, I'm not going to talk more about NAT because we have to understand NAT about the source NAT, what is the use case going to be happen and how the packet processing is going to happen, what is the destination NAT is going to be happen, then how the packet is going to be happen again processing. So there is a special note here. So I didn't read this all. So hold your thoughts. I'll explain. But yes, definitely NAT lookup is going to happen for source and destination both, but it's just evaluation process. The implementation of NAT is going to happen always in the fast path. That's also crust. You have to note it down. Okay, I'll discuss more about this NAT when we have to discuss this NAT concept. All right, so when I just discuss this NAT, 4 type of NAT we have to understand: source NAT, destination NAT, U-turn NAT, dual NAT. So we'll discuss this all things in very detail. Now we have to do the policy, decryption policy, and based on that decryption policy, we have to decrypt the packet. What does mean decryption policy? One, decryption we have done for the IPsec and SLVPN packet. Now you're doing the again decryption. What does means? What the hell is happening here? Why there is multiple decryption is happening? No need to worry at all. This packet is your IPsec based packet. This packet is your pure SSL based packet. SSL encryption, LSL decryptions. This is the IPsec VPN packet, SL VPN, not like encryption. So any packet which is the HTTPS, right? It's having an encryption, decryption based on the certificate. That is known as, if you go in any website, let me go here in GoINET website itself. You are going to find, if you go here and just go in the connection secure certificate, you have see these are the certificate are Let's Encrypt company. They are just encrypting certificate and key and all. So every website you are just handling, they are based on the HTTPS. So whatever data you are just processing from that particular website, that is not going to understand by the firewalls. Even you are transmitting the virus, vulnerability, DOS, any bad URL, any bad DNS, those all are not going to be understood by the firewall. So in some situation, even we have to decrypt the encrypted packet, which is the highly secure packet, to just understand what is going on this particular packet. And that's why decryption is going to come into picture. So you don't have to worry about that. We have the special engine in the decryption section. You can see here, we have the SL decryption. Once we understand how decryption engine is going to work, then you guys will definitely understand this section. Now, if decryption is there, then it is going to be happen. If there is no decryptions, then it is going to check the application. That is a layer 7. What is happening in my packet as a layer 7? And also they are going to check what is the content of this packet. Means we done with the layer 2, layer 3, L4. But now layer 7 is your application. You are accessing the Facebook application, Instagram application, Google applications, Gmail application, right? YouTube application. And inside of that application, what content even might be you're accessing accessing the Teams application. And inside of Teams, you are just sending the Excel file. And that Excel file might be protected from your network, should not be shared to any other company network. So in that scenario, also, you have to inspect the content as well. So layer 2, layer 3, layer 4, layer 7, and the finally data. That all processing and inspection is going to happen in the fast path. And some of the application might be not available in the Palo Alto database. We'll discuss what is the application engine. So in that scenario, we have the separate application identification engine. In a Palo Alto, we have the lot of application. If you go in the applipedia. If I just go applipedia.com, these are the Palo Alto applications. So if I go here in Palo Alto application, see, total we have the 4,762 applications. So if you want to check any application, right? You want to check like YouTube application that is going to be available here. You are going to find the YouTube applications. See here. Even you're going to find the WhatsApp application that is going to be available here. So you're going to find the WhatsApp application as well. So we have a lot of applications which is available in the application. This is what is the application. Some scenario, my application is not going to recognize by the Palo Alto application engine. So they move to that recognition in the special application engine where they are going to check the application which I received that whether we have the application override policy. Means override policy, I don't want to match the application. Override means I don't want to match the application. I just without checking the application, I want to process the traffic. Means I want to process check the layer 2, layer 3, layer 4 and content, but I don't want to check the application. Means I want to bypass the application. So that is the override policy. So if there is override policy, then definitely security policy next is going to be checked. If there is no override policy find, that will try to check based on the signature, content, application pattern, what is the application behavior, and based on that they will just try to allow or deny based on your security policy. So that's why this application engine is going to come in a picture, and based on the application, they sometime what is happening. Let's suppose you are accessing the Facebook. User allowed to access the Facebook, but not allowed to access the Facebook chat or video call. So might be at a first place, your application Facebook is going to be allowed. But suddenly what user behavior has been changed. Suddenly you start doing the chat. So it will trigger again, hey, something wrong and it should be blocked. So then it's a content inspection is going to become in a picture based on your behavior. An application has been changed which is blocked, then your application is going to be blocked. Are you getting my point? So this also we have to understand, right? So application engine having a lot of responsibility. They have to do a lot of checks based on the pattern, based on the predefined application, based on the custom application, based on the application behavior while accessing the application by the users. And then finally, once we're done with the SSL inspection, let's see, we have the rule matching, packet discard, again, content inspection engine again here, and SSL encryption, decryption, which we discussed earlier. That is, if decryption is going to happen, before sending out the packet, we have to decrypt the packet. So it can be under the application or under the content inspection, both. So application is most important. Then we have to put major resource to check the content, because content is the one thing where we have the all loopholes in terms of the virus, in terms of the malicious content, in terms of the any kind of the vulnerability, any kind of the spyware, any kind of data leaking, any kind of the file, URL, whatever you want to send, that always going to fall under the content inspection, guys. So that's why I'm saying after like application engine, the packet is going to be processed for the actual, just for the content, means data, whatever data we have, whatever the payload we have, and they are going to check like content matching, any application which is going to even tunneled or non-tunneled traffic. Based on the content, if any behavior is going to be changed, right? Based on that, they are going to direct any kind of inspection which is applicable, not applicable for the SSL decryption, encryption. If it is applicable, then it is going to be processed for the apply the security policy. If it is not, then it is going to re-encrypt the packet if it is already decrypted in the first place. So these all processing is going to be happen. Let me show you if I can log into the firewall, how it is going to look like. So you guys can little bit have a view how this content inspection is going to be look like. Let me see that. So what is the IP address? Let me check. Just give me, come on.
Sir, application content inspection and the data content inspection are same or different, sir?
Yeah, same. Content and data is same.
Application content and the data content, both are same.
Yes. Application content is actually data also, right?
Yes, sir.
Means you're doing the Facebook chat, right? And you're uploading one of the Excel file. That is also application content, na? So that also the part of the, check that what kind of application you are sending, what data you're sending. So it's a very realistic scenario. It all work together, right? And firewall have the advanced feature who can understand each and every transitions. Let me show you how it is going to be look like in the content point of view. So see, if I'm going in the policy, right? These policy, when we create that, we have to create together, right? In everything. See, this is one policy. Let's suppose the packet is processing from trust to untrust. You don't know right now what is trust, what is untrust. I'm assuming that, but just listen to me, okay? If this packet is going to be processed, you can just match the source IP address, destination IP address, that is a layer 3. Your application is layer 7. Your port, that is a layer 4. Your URL also going to match. What about the content? So content here you can match. Means actual data you are sending, which have the any kind of the virus, vulnerability, spying activity. You have the file blocking, you have the data filtering, wildfire analysis. So a lot of things are here. You just have to monitor, and based on that, you just have to take an action. So you'll see we have a dedicated chapter for these all. The content inspection, application inspection, file blocking, wildfire. So you don't have to worry. Even that's what I'm saying. We are starting from here, but we are going to end on this particular topic only. So you are going to get entire flavor. So the content inspection is going to be happen based on the content inspection. The packet processing is going to be happen for the next stage. That is a final forward and egress stage. And in this stage, what is going to happen? Packet forwarding process is going to happen. But before packet is going to be transmitted, again, we have decrypted the packet. That was the IPsec. Also, we have decrypted the packet when I receive the packet. So this should be also re-encrypted before sending out the packet from the network. So my packet must be transmitted. My packet must be transmitted. But before transmitted, if my packet is IPsec, that should be the also encrypted. Clear? Then this is how entire packet processing is going to be happen. Most important thing, this section is going to be complicated, you guys, because you have to understand how the routing NAT, source NAT, destination NAT is going to happen. Policy is pretty simple. Now you have to understand how decryption is going to be happen. Then we have to understand when I just explain the decryption module, right? Then you have to understand the entire application. What is the application override? What is the pattern base? How we can create the custom applications? How the security match is going to happen? How the based on the application behavior content is going to be changed? Then how the decryption encryption is going to happen and how the file is going to block? That we have to understand. Then finally, pure content means we have the virus, antivirus, file blocking, data leaking, spyware, that also going to be checked. So these all having a different module. So this is the just complete explanation about the life cycle of the packet. Rest we have to split each and every section in the upcoming classes, and we have to do deeper side understanding about this packet flow. Ask me if you have any question, because I have done this all explanation for this, how the packet processing is going to be happen for the flow logic. Please let me know if you have any questions, guys. All good? Okay, so if you all good, guys, right? So from Monday onward, right? This will be a regular class. There is no any gap. Okay. from Monday onward, right? This Monday onward. So there is no any single gap. We'll have to do 4 classes in a week. So be ready for that. We have already a lot of time in the past, right? We have done a lot of basic discussions. So next class is again going to be theory class, where we have to understand about the single pass architecture with the parallel processing. So this is the one questions very important. This is second question very important. What is the SP3 architecture in the Palo Alto Firewall? So we have to understand. Then we start doing the more configuration, right? And at the same time, we'll means the ratio is going to happen 70% configuration and 30% theory after that. Because more and more you have to do the configuration, more and more clarity you are going to get. Theory automatically you're going to understand. Once you understand the complete packet processing, how the packet is going to be happen in the Palo Alto Firewall. All right. So wish you all the best, guys. Right. And I know it's a festive season, festive day for you all. Right. So wish you all the best and see you again in the next class. Right. Okay, Anurag, noted your point. Okay.
Okay, sir. Okay, sir.
Thank you.